Hello, everyone. First of all, I would like to thank the organizer who organized the event and invite me here. So I would like to talking about from the high energy physics to the high performance computing. So I think this is one of the key keywords that we are talking today. So let's go to what we are doing. I think this is what Martin already tell you the story. So we are particle physics experiment. So basically we are statistical experiment. So we need to collect the data, and our data is quite big. So we have the collision beam crossing every 25 nanoseconds. So it means that in 1 second we have a collision about 40 million events, and that's super big. So we cannot really manage that. So we have to trigger or select the event of interest and make the physics result out of that. So that's why we need computing resources in a big infrastructures, also powerful software to analyze this data. So what I will tell you, it's about how we use the HPC and what is the opportunity from Saudi Arabian to join and doing the person powers improvement developments. So let's start from the Monte Carlo side. So from the collisions, so we need to first collect the data. We need to compare it with the computer simulations. So in our challenge is that how can we do this one and represent well the data that we collect. And that's giving our chance to, the current technology giving our chance to go deep into that one. So including the quantum computing, including the GPU accelerations, and including also the AI and the machine learning developments. So let's go a little more on that. So when you collide the protons, so at the point at the collision, so you can see from the red one, so that point is what we call the perturbative calculation. So that one, it's basically explain the real physics content that we would like to get from. And that can be used with the classical computings, but it can also improving with the quantum computing to speed up the calculations. This is one of the bottlenecks we have, because now this process takes 20% of our computing resources. After that, when the proton collide, it starts to be hadronized. So you can see on the green one. So it's real shower that you see on the picture of RSC experiments. So that one is a non-perturbative calculations, and that we need a quantum computing for that. The current classical one can do only the approximations for this one. So basically, we want to use the quantum computing to compute the quantum process. So that is the key point, that why we would like to develop the quantum computing for these experiments. Next one is opportunity with the GPU. So nowadays people talking about CPU, and also this morning talking about the GPU. So how can we accelerate the full event processing? Because if we can do the computing faster, it means that we can process more events. So if we can process more events, it's possible that we can find the rare physics process, right? Because some physics is rare, very, very rare, like 1 in the billion. So that we need to go with that. So with the GPU currently in CMS, we can offload about 50% of CPU calculation, so that we can have more output of data from the current trigger systems. So next challenge is that can we offload more to GPU? So targeting that we can process about 100,000 events per second with the full event size at the computing centers. So this is our targets. After that, when we try to do the simulate really what happened in our detectors. So we do step-by-step walking of the particles. However, we try to make it fast, because this simulation process takes 50% of CMS computing resources. And with the machine learning and AI, we can make it super fast. Instead of 20 seconds for one event, we can do 1,000 events per second. So it's 50 times faster with the machine learning technique that we learn from the full simulations. So this is very challenging for us. And this is what we target for what we call Run 4 RSC experiment, which is going to start in 2030, so 4 years from now. So what is the size of data that we are talking with, right? So this is from 2021 source, so you can see if the big circle, it means big data. So you can see that the RSC raw data, it's super big in that way. But we can, because we cannot analyze that, so we need to squeeze it out to be this small green one. Okay, so there's a lot of data that we need to throw away. And that is maybe the physics that we really need to discover the new physics. So that's why we are really eager to improve on this calculation. So from the data processing and the data storage point of view, so this is a projection that we had from 2022. We're going to update a new one maybe in the next few months. That when we upgrade the machine to what we call the high luminosity RSC, we can collect more data. And to collect more data, we need to make sure that we have the computing resource enough to do that. As you can see, if we don't do any developments, the solid blue line gonna blow up, and it's more than 20% that we need to buy more computing resources. But with the AI, with the GPU stuff, we can lower it down within the budget of 20% increasing of the resources. But this needs a development, and this is person to do that. Okay, the AI that we have today cannot really do it for us. We need physicists and we need computer engineer to help us for this step. And this is how the CMS data processing look like, but maybe I can script this one to go to the features of what we are looking for. So when the machine is collecting the data, we really need to process the data quickly, because this is when we finishing the process of data, physicists can analyze that one and release the result quickly. So if we collect it today and we don't have the computing resources, physicists may need to wait another years because there's top up of the event that we are collecting. So today, what we are doing is that our computing resource itself is the green one. So this is the resources that we can process at CERN. And then the yellow one is also what we can process at CERN using the old resource we have. But you see that this is not enough. So what we have to do is that we need to distribute the resource to our tier 1 computing centers, which is in Europeans and in US, to help us to do the processing, so that we can make 7 kilohertz, so 7,000 events per second of data that we collect in one shot. Okay, so people don't need to collect and waiting for another years for data to process this one. And this mechanism works very well. So we use the whole resources we have. You can see that at maximums, we go to the 26.2 thousand core CPU to process this whole data. So in Run 4, we would need more, so that we would need a contribution from all the countries, help us together, going together to study this physics. And then during the, let's say what we call the machine development period, so when we don't collect the data, so we use this computing power to make the Monte Carlo production for physicists, so that they can compare between real one and the computer simulation one. So you can see that the whole years, we quite stable with the CPU we use and the number of events we are processing. So that is help us to push for the physics results quicker. So running the big computing resources, what do you need to what the country can get from you, right? I mean, what the country can get if you run this one. So this is the question that all the country asks us when they want to contribute, when they would like to contribute the resources to us. So basically, it's the technical, it's national technological leadership and innovation. You have a big committing resources. People come to use it, share that, and then create a new things, create a new physics, new knowledge for that. It be strategic national infrastructures, because when you have a big computing resources, you gather all. It's not only physicists but scientists in the country to come to work together using the single infrastructure. CERN is the same. It's not just the particle physics, right? I mean, the resources that we use is sharing on different sides, biologies, and during the pandemic, we also use this one to unfold the structure of the COVID virus. So that you can see that the benefit to have a big computing resources. It can be scientific leadership and the global recognitions, because if you're hosting the big infrastructures, everyone can say, you are ready for that, you are ready to manage the big data. So that is the leadership you're gonna get. The most important one is the skill that you use. So you develop the person skill on the high performance computing management, the distributed computing, the big data management, and also the cyber securities. So this is what we train for people to working for us. So when people finish the project from the RSC, that can continue on the academia, or they can move to the industry side. So because they are trained to prepare for this one. And the data set that we are talking about is petabyte scales, so it's quite large, with a global scientific network and the analysis facilities serving for the Asias or for the worldwide. Okay. So this is the I think this is Martin mentioned already. So in CMS collaboration, we have CAS that already member of the CMS and also efforts, right? So both are very focusing on the computer engineering, computer side, which is, I think this is perfect fit for us to contribute to the collaborations and even the project that already start with the CMS. Just to give you an idea, so this is based on my experience, so maybe we have better experience. So I was a summer student at CERN in 2004. That time, I'm only one at CERN. Maybe I'm the second one at CERN from Thailand. And after that, when I start to grow up on that, I start a PhD, moving to CERN, working there, and moving the country to the CERN things. So we start to join CMS. We create the ICA. More universities in the country come to join different experiments. We start to doing the hardware also with the HP and also the computing HPC. And I grow up, and then I start to learn, maybe I'm fit well with the computing programming, so I become the CMS offline computing coordinator after 20 years. So I think this is what we're thinking about, I mean, for the new country. So I think that this is good fit for Saudi Arabians, that if you would like to move in, develop the person powers, and gather the people together for the countries, yeah, I think this is the good thing that you should have a look on that. So yeah, I think this is all from my side. Thank you very much.